It's
Yes, dear.
made of many
What is the meaning of
monomers.
polymerization?
Um, when monomers form one larger
What
polymer,
is a monomer?
it's this single unit
Yeah,
of
okay, you're very right. So suppose I have this compound CH2 double bond CH2, okay?
I
And,
can't see the
oh,
box.
oh, oh, I'm sorry. Can you see it now?
Yes.
Okay, suppose I have another molecule and I have another molecule and I have another molecule. So these are the molecules of ethene, right? So what is happening now? Look here. The bond from this carbon will shift to this carbon. Then the bond between these two carbons will shift to the next one, right? That this bond will shift to this carbon. So these small units will combine together to form a large molecule combined with a single bond. Okay?
Yes.
When two molecules combine together, this is known as a dimer. When three molecules will combine together, it will we say it as a trimer. And when we have more than three, we say that it is a polymer. Okay? Mostly our
Yes.
plastic is actually belongs to this family. And you can see if we have n numbers of these compounds, we'll polymerize it to the n. So in general words, we can say if we have small pieces, small powder-like powder of plastic, okay, when I melt all the plastic, what will happen? When I will melt this plastic, I will get a sheet of plastic, right? All the plastic pieces will combine together to form a sheet-like structure. Okay, so
Yes.
these are monomers and this is a polymer. Okay, so now let's go in more details. When we say about the general types of the polymers, there are actually two basic types of polymers. Can you tell me what are the two types?
Um, the two types of how they are formed,
Yeah,
addition and condensation.
very good, very good, highly appreciated. Okay, so we have addition and condensation. You are familiar with the example of addition. Just I'm just writing it over here. Let's suppose I have n numbers of CH2 double bond CH2. So they will combine together to form long chains of this polymer up to n numbers. Okay. You have different types of group here as well. For example, you have C, X, and Y, double bond C, A, and B. So there can be different groups as well. So you will get the groups over here. Okay. This is known as addition polymer. Now, what is condensation polymerization? These are addition. Second one is condensation. What is the meaning of condensation?
The reaction forms water.
No. Why you are like you are making a limit on it? how you can impose a limit on condensation, that condensation means water. Condensation doesn't mean only water. A small molecule, it can be a water molecule, it can be an HCl molecule, it can be ammonia molecule, any small molecule, okay? For example, if we have CH2 whole 4, CH2 OH, CH2 OH, and I have, suppose, HO. Now, H and OH will combine together to form
H2O.
H2O. Okay. CH2O. Let me change the color. Okay, so can you see? They're combining together by removing a small water molecule. So this is condensation. We can have another example here. Suppose I have this group. Am I audible here?
Yes.
Okay, now see. H from this side and Cl from this side. Okay? So in this
Yes.
case, what we will get? We'll get small HCl molecule. And we will get this polymer like CH2. Okay, so we'll get the long chains here. So we cannot say that condensation polymerization means the only release of a water molecule. It can be any small molecule. All right?
Yes.
All right, all right. So that's very simple. Now, okay. So we have 2 points here to read. Let me select the points. Okay. A repeat unit is the as between is a specific arrangement of atoms in polymer molecule that repeats over and over again. And the second thing is the repeat units is always written in square brackets. Okay, that is why I'm
Mm.
writing these brackets. After the bracket, place the letter N to show that the large number of repeating units. All right,
Yes.
N number of this and N number of this. All right. All right. Now we'll see the polyethene. That's very simple. We discussed this polyethene just at the start. So I will just tell you, show you the structure and we'll move onward, okay? This is the topic. So you can see here polyethene, and we can write it here like this. Okay. All right. Can you understand this one?
Yes.
Okay. This bond is shifting here. Okay.
Yes.
All right. Polychloroethene. Okay. That's very important. If we have a structure like this, CH2 bond CHCl having a double bond. So what will happen now? When the n numbers of this ethene chloride, okay, this is ethene chloride. Generally, this ethene is also known as vinyl, okay? The common name of this ethene is vinyl, okay?
Yes.
So when we'll polymerize it up to n numbers, CHCl polymerizing up to n numbers, so we can write it as polyvinyl chloride. Do you know what is polyvinyl chloride?
Um, it's used for a lot of um
PVC plastic, the PVC used in pipes, the plastic, general plastic we use in our daily life. Okay,
yes.
it is okay. Now, look. Okay, I have a question for you. I have a question. Suppose you have a polymer. Identify the monomer. So if I have this structure, okay, suppose I have this polymer. Can you tell me what is the monomer here?
It would be like where you split it in half and one side of it is the monomer.
Sorry?
Um the C and the CH, and then after the CH, it's that one unit is the monomer.
Okay. Uh, This one?
And no, the one before the first carbon and the second carbon.
Okay. So you want to say this is the monomer, right?
Yes,
Good, 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 good. Okay. Let's give another example here. Because this will be the part of your paper, okay? They will give you a polymer and they will say, what is the monomer? Find the monomer. All right, dear. Suppose you have okay. Can you tell me? Oh, sorry. My bad, my bad. This one. So, first of all, identify the monomer.
it would be first three, the first two carbons and the NH.
First two carbons.
No,
These,
and the NH.
this one. So you want to say
Yeah.
this is the monomer?
Mm. Oh, is the whole thing the monomer?
You have to find. Okay.
Hello?
Yes, dear. Tell me. Answer. Give me the answer.
Isn't the entire what's in the bracket the monomer?
No, dear. The entire
Oh,
compound cannot be the monomer. Why you are doing it wrong? See, you are actually trying to find where is the double bond. Every monomer, every polymer is not formed by a double bond. First of all, identify the type of polymerization. So which type of polymerization it is?
uh, addition?
No, it's not addition. It's condensation polymerization, dear. Okay, it can be a question. How? It can be a how we can identify whether it is condensation or addition. So anywhere you are getting C double bond O and OH, it is condensation. You are getting C double bond O, C double bond O, this type of situation, it is also condensation. If you are getting NHO, NH, it is always condensation. Okay? So if you
Yes.
have like O, this type of situation, only O with like a bond, it is also mostly it is like 99% they are condensation polymers. So we have to break the bond. Okay, let's see from where we'll break the bond. We'll have to break the bond here and then break the bond here. Okay,
Okay. Yes.
so we'll break the bonds and what we will get, we'll get the monomer. The monomer is CH, C double bond O, and definitely we are removing a small water molecule from this. So we'll get C double bond O, OH, CH3 is attached here, and we have NH2, CH, CH3, C double bond O, and OH from this side as well. Okay, plus this NH2, making a whole compound. So this is known as amino acid. This is amine group, and this one is an acid group. Can you tell me where we amino acids are used?
uh, to make proteins.
Yeah. So it's actually a peptide linkage. All right.
Yes.
It is peptide linkage. All right.
Yes.
Okay. So we have to identify the polymer type, and we can identify it by just looking at the structure. Okay. Now we'll discuss about something about Teflon. Teflon. It is actually very useful plastic. It is registered, it's a trademark as well. So Teflon is formed by polymerizing CF2 double bond CF2. When n numbers of this monomer will combine together to form CF2 up to n numbers. Okay,
Yes.
so it will form up to n numbers, and this is Teflon. Non-sticky pans, the roof, the prepared roof walls, and the roof flooring is actually done by the use of this Teflon. It is actually a very hard type of plastic. Okay, even hydrofluoric acid is a very dangerous acid, and it can dissolve glass as well. So we cannot put hydrofluoric acid in glass even. It will dissolve the glass. It is stored in Teflon. Okay, it is very non-reactive. Okay.
Yes.
Now, identifying the monomer from the polymer, as I told you, but look, let me make the structure. Okay, look, you have a situation, all right? Find the monomer here.
Is it the area that's in yellow?
Yes. Okay. If we'll break the molecule here, so I will get the monomer like, so which type of polymer it is?
A condensation?
Sorry?
Um, addition.
Yes. Good. Okay. If I'll break this molecule from this side, then which type of polymer it will be?
A condensation.
Yes. Okay, good, good. Now, these polymers are actually very dangerous for the environment. Can you tell me why the polymers are dangerous for the environment?
Are they harder to break down?
What what do you mean by breakdown? It's harder to break down means it's very like reliable and durable. If the compound is not decomposing in environment, then definitely it's important. Then why we are saying that they are creating some environmental concerns?
Hmm.
If a thing is durable, it is not decomposing. Don't you think it is useful for the environment?
Mm, no, because it would be harder to recycle.
Sorry,
And there would be more issues when trying to
like
recycle it.
okay, look, it's very important to understand environmental concern. If I have a bottle of plastic, look, I have a bottle of plastic, and I am drinking water from that. I'll use the bottle and then I'll throw the bottle into the dustbin, right? Do you think
Yes.
any other person will take the bottle out from the dustbin to use it again for the water purpose, for filling the water again?
No.
No. So what will happen to that bottle? This plastic will stay in the environment and it is actually useless now. Why it is useless? Because if I want to decompose this plastic, the only solution is to burn. And the burning of plastic will release such a catastrophic chemicals and gases that are not useful. It will form harmful gases. Okay, so one can say, okay, dump it into the river. So definitely, if we are dumping so much waste into the rivers, oceans, it will pollute the water, contaminate the water, and will create serious concerns for the marine life, right? So rivers, harmful gases. So what we can do with this plastic? One time we are using this plastic, after that we are not able to use it in a proper way. So this plastic is actually a problem because it the environment cannot break this one. Suppose you are eating an apple, okay? Just take the example. You are eating an apple, not iPhone, okay? Remember, one it's a very interesting story. When once I was teaching and I told my student, suppose you are eating apple, and he said, Sir, I love my phone, so please don't tell me that I will eat it. I was saying, not Apple iPhone, dear, a regular apple. An apple away a day keeps the doctor away. That apple. All right. So suppose you're eating an apple. You'll definitely remove the peel, right? And you will eat the apple. What will happen to the peel of the apple after 1 to 2 days? Yes, dear.
Will biodegrade?
It will get degraded, or like it will degrade. So, uh, uh, we'll peel the different peels of different fruit, like you're taking oranges or any other fruit stuff on which you are removing the peel. The peel will decompose after some time automatically, and we do not need any material, or we do not need to burn it. We do not need to do anything with that. But plastic is not going to decompose itself. It means it will stay in the environment. It will pollute the environment. It will pollute the land. It will pollute the rivers. It will pollute the sea, like the water bodies and other parts. And if we dump it into the underground, then definitely how much plastic we can burn under the earth. It's very difficult to dump all the plastic under the earth. It's a very serious concern nowadays because a lot of plastic is produced every year, And the recycling of this plastic is also very dangerous. How this plastic can be catastrophic? Look at this picture. This cute tortoise, turtle is actually a turtle, okay, which is actually dead now due to this plastic. You can see it is actually stuck on its
Yes.
mouth. So plastic weight, harmful effects are very dangerous, right?
Yes.
All right. So now you can see that this plastic is very dangerous. I have a picture. I have a picture. Let me just show you that. Okay. Look at this plastic. Oh, it's loading, it's loading, it's loading. Yeah. Can you see this whale?
Yes.
Oh my God. What a waste. It's a big whale which which is dead now due to plastic. And I have another picture. Just for your concern, I'm adding it over here so that you can understand that this is non-biodegradable and it is very catastrophic. So nowadays, scientists are working to make a plastic that can decompose or will decompose itself. Okay,
Yes.
so that biodegradable or photodegradable polymers are produced, and these photodegradable polymers can decompose under the sunlight. Suppose if someone is dumping that plastic uh, on land, then whenever the exposure of light will happen from the sunlight, the plastic will automatically decompose. Okay,
Yes.
they are known as bioplastics. Look
Yes.
here, biodegradable, the photo degradable polymers. So these polymers can degrade or get degraded under light. Okay, there's a microorganism in water as well that can decompose. Similarly, one very interesting thing, research actually, which I was looking in my university, that the students were trying to develop a plastic from plant material. Can you tell me what is the beneficial purpose for this plastic from the plant material?
Um, it will be able to biodegrade.
Yeah, and one interesting thing is that when we are making it from the plant material, if we are dumping this plastic on the ground, it will be absorbed by the land for making new trees, for the growth of new trees, for the growth of new plants, and for increasing the nutritional value in under earth or the on the earth, right? So the micronutrients and macronutrients are also increased in the earth when we dump this type of green plastic on the land. Okay, dear?
Yes.
Okay. Okay. So we have a question here. Let's solve it and we'll move to the next topic then. Yes, dear. Section of all long. An addition polymer. Identify the repeating units and skeletal formula of the all long. I think the question is easy for you. Okay, take it
Okay.
as an home assignment and just send it up to the class. Okay.
Okay.
Okay. Okay. It's a very interesting question. Okay, let's solve this question here. Okay, so let's solve this question. Reduction of a branched alkene A with hydrogen formed a compound B. On analysis, B had the composition mass carbon 82.8% and hydrogen 17.2%. Reaction of A with steam in the presence of a catalyst produced a mixture of two isomers C and D. Can you tell me how we can find that which compound it is from A, B, C, D? What do you think? What we can do?
Try and work out the empirical formula.
Excellent. Good. Go with the empirical formula first. So in this question, the first step is to find the empirical formula. Okay. So I told you in last lecture that how we can find the empirical formula, right? Okay. So for the empirical formula, we have the percentages of carbon and hydrogen. The carbon is 82.8%, while hydrogen is 17.2%, right?
Yes.
Okay, sounds good, sounds good. So how we can find this is the percentage. So we'll divide it by the atomic weights. So 82.8 divided by 12 is equals to,
Is 6.9.
and what about hydrogen? It's almost 17.2.
17.06.
Okay. Now, which one is smallest number? 6.9.
Yes.
Okay. So we're dividing with by the smallest number. So when we divide it by the small number, it is 1. Ratio, what is the value here?
2.47.
3.47.
2.47.
Sorry, 2.47?
Yes.
Okay, 2.47. So what we can do now? We have, we need a suitable number because it's not a whole number, right? So we will multiply this number with a number to make it a whole number. Okay? That's the
Yes.
rule in empirical formula that when we'll divide it by the smallest number of gram atoms, the ratio we are getting, if not a whole number, then we'll multiply it with a suitable number. So we'll multiply it by 2. So it will become 2, and 2.47 is multiplied with that is equal to 4.94, right?
Yes.
So it is approximately equals to 2 into 4 and 5, right?
Yes.
So we are getting C2H5. Okay, 2.47 multiplied by 2 is 4.94, approximately equal to 5. So the compound is C2H5. Reduction of a branched alkene A, hydrogen form. Okay, so we are doing a reduction. Okay, so which type of compound it can be that is formed by the reduction of a branched compound? That's very interesting to understand. Reduction of a branched compound A. Okay, with hydrogen. Oh, that's the empirical formula. We'll find the molecular formula. Okay, this is empirical formula.
Yes.
And how we can find the molecular formula is equals to N multiplied by empirical formula. So what we can do now, that's very simple. Empirical formula mass. Oh, sorry, empirical formula. Okay, look, what is N? N is equals to the molecular mass mR divided by empirical formula mass. Okay,
Yes.
so the molecular mass of the compound is given in the question, which is 58 divided by the empirical formula mass C2, carbon 12 into 40, 24 and 529. The empirical formula mass is equals to 29. So it is equal to 2, right? So 2 multiplied by C2H5. Am I audible?
Yes.
So we'll get C4H10. Okay, so the formula of the compound is CnH2n plus 2, right? This is an alkane, so this is B. Okay,
Yes.
now we are able to find the B. Reduction of alkene, branched alkene. So A will produce the mixture of isomers C and D. Okay, it's a branched alkene. We have 4 carbons with branch alkene. Oh yes. Do you think it's a branch alkene with
Yes.
4 carbons? That's the only possibility. So it is A. Interestingly, we are able to find A after the B. Okay, now when we will do the Okay, okay, I'll tell you. Explain the whole question in the last as well. Let's find C and D. When we will add water in this, we'll get two polymers. Either we'll get CH3, CH, CH3, CH2. Look, either we'll get H here and OH here, or OH here and H here, right? On two different
Yeah.
positions. So it can be C and it can be D. Okay, can you understand
Yes.
this now? So
Yeah.
let's start from A to solve the whole question. A compound is actually CH3, CH, double bond CH2, and CH3. After hydrogenation, it is known as reduction. We are adding hydrogen in the presence of nickel as a catalyst. 250 to 300 degrees Celsius is the temperature condition. So we'll get CH3, CH2, oh sorry, CH, sorry, my bad, why hydrogen here? So, okay, CH, CH3, and CH3. Okay,
Yes.
and if I will reduce, or see, if I will add water in this A, we'll get two possibility, CH2. So possibility is simple. H, OH, or OH and so this was A, this one is B, this one is C, and this one is D. All right, dear?
Yes.
All right. Okay. All right, all right. So the next question. Okay, that's is linked. This question is linked with the nomenclature. Okay. Can you see the question?
Yes.
3-bromo, 4-chloro, pent-2-ene. Okay. Okay. Pent-2-ene. Pent-2-ene. Okay.
Yes.
So one, two, 3-bromo, 4-chloro. Okay, this one. Okay,
Yes.
so this will undergo addition polymer. Okay, write the equation for the elucidation of this. Show clearly the repeating unit of the polymer. Can you do this? Please just take a few minutes to draw this and send it to me quickly.
Yes.
Okay, so this is your answer. Now, what the mistake you're doing? Look, one, two. Okay, we have double bond here and this one. Okay, that's the wrong way to represent the polymer. Okay, can you hear me?
Yes.
Okay, rearrange it. You are making a polymer from the double bond. It is CH3, CH, double bond C. With the C, we have one Br, and now we have, okay, we can make this polymer like this. CH3, CH, and here we have CH, CH3, and Cl. All right, that's the unit. So you will just highlight the double bond. Okay, now you'll make
Okay.
another double bond here, the repeating unit, and then you will make another repeating unit. Okay, now look. Okay, so Amarva, we can make it like C, CH3, Br, C, Cl, CH3, making a polymer bond here with this C having this CH3 group, with this C attached with carbon. Okay, so they are showing the repeating units. All right, dear.
Yes.
Can you understand it now?
Yes.
So it's very, very simple. All right, that's the end of the chapter. You can look here. We'll start from alcohols from the next week. Okay.
Yes.
If you have any question regarding to the previous topic, you can ask here.
I don't, but when will we have the extra class to make up for yesterday?
Uh, just- today is Friday.